let's go over series and parallel resistors. It's going to be great. Okay, so we'll start with the simplest case of, let me actually start with Ohm's law. And this is going to be a little bit long, but I'm going to, it's as long as it needs to be. Okay, so this is Ohm's law, which is not really the best way of writing it, but I'm going to write it anyway. This says if you have some device and you can measure the current through the device and the potential difference across the device, then this is true. And let's just say that it is. Okay, this is for ohmic resistors, and I mean, there's some case where it doesn't really work. But this says that the voltage is the current times resistance. So that's all great. Here's my resistor, R. Here's my current going through it, I. And then here's delta V I like to put, but everyone just calls it V, so whatever. Okay, but now what if I have resistors in series? I think a good definition of resistors in series is when you have two or more resistors that all have the same electric current going through them. So here's one case. R1, R2, I. So here's current coming through. It goes through resistor 1, and there's nowhere for it to go except to go through the next resistor. I feel like I'm on the wrong side of the board because you can't see me. What if I move the camera right here and turn that? Is that better? I don't know. I'm worried about that thing right there, but oh well. Gonna go on anyway. Okay, so how do we find what we want to do is to find the equivalent resistance. And that's the resistance for if I want to replace those two resistors with just one or three. So let's just look at Ohm's law right here. So I know I have the current I going through there. Well, I have a V, I'll call it V1. That's the voltage across that one. And I have V2, that's the voltage across that one. So if I get the total voltage, I get V equals V1 plus V2, right? I have to add up the voltages. And so if I take that one resistor R1, the voltage across it is going to be IR1. So this is going to be V I R1. And that one is going to be plus I R2. They have the same current. Okay. Now I can factor out the I. So I get V equals I times R1 plus R2. And there you go. This says that it's just like this. I'll call this R equivalent, where R equivalent is equal to R1 plus R2. So if I have a 10 ohm resistor and a 20 ohm resistor, this is exactly like a 30 ohm resistor. Okay, so that's the equivalent resistance in series. What if I have 10 resistors in series? They all have the same current, so they'd have that same I that would factor out, and I would get this R1 plus R2 plus R3, blah, blah, blah. Okay, so that's series. So this is the important part. I'll put it up here. R equivalent equals R1 plus R2 plus R3 plus dot, dot, dot. Goes on forever. Okay, now let's do parallel. I still have that. I'll delete it up. And then I'm going to do an example. Don't worry, I'm going to work out an example. Okay, here is two resistors in parallel. R1, R2. So resistors in parallel do not have the same current. And in fact, if I have a current coming in right here, I, then some of it goes through resistor 1, I'll call that I1, and some goes through resistor 2, I'll call that I2. And since current is conserved, then I is I1 plus I2. But they do not have the same current. They do have the same voltage, the same potential difference. If I measure the voltage across this resistor, it has to be the same as that because there's nothing in between them. So they have the same voltage. So let's write down Ohm's law for this. Let's say, okay, so I know that the current, they have the same voltage. So for resistor 1, V equals I1 R1, and V equals I2 R2. But they have this. So if I solve for the current, that's what I want to do. Solve for the current. So I1 is V over R1. I2 is V over R2. Okay, I've kind of forgot this derivation and decided to remember it. Okay, so now let's find the, let's say that this is just one resistor. I'll call it R equivalent. Then I could say V equals I, R equivalent. But I is the total current going through that, so this is going to be I1 plus I2 R equivalent. And then right here, look what I got. Look what I got right there. I'm going to put in this for I1 and that for I2, so I get V equals V over R1 plus V over R2 times R equivalent. Now I'm going to divide both sides by R equivalent, and I get V over R equivalent equals V over R1 plus V over R2. And the V's cancel. So in parallel, I get 1 over R equivalent equals 1 over R1 plus 1 over R2. And in fact, if I had 3 resistors in parallel, then I'd have I1 plus I2 plus I3, and I'd have 3 terms there. So you could just keep adding on terms if you need. Okay. And that comes just from Ohm's law. Let's do a practice. I already did one for series, and I think that's pretty easy. The one that you're going to make a mistake on is parallel. So let's make up a resistor circuit in parallel and find the equivalent resistance, and then I'll do a more complicated one. Yeah, that's what I'm going to do. Okay. Okay, so let's say I have I want to do one where the math is easy. Well, that's fine. I'll do a 20 ohm and a 40 ohm. So R1 equals 20 ohms. R2 equals 40 ohms. So I'm going to find the equivalent resistance here. So I'm going to write it like this. 1 over R equivalent equals 1 over R1. I'm just going to leave off the units, 20, plus 1 over 40. So it's going to be 1 over R equivalent equals, I need a common denominator. Here's where everyone makes a mistake. They're like, oh, fractions, it's just 1 over 60 or something like that. No, it's you still have to add fractions. Don't forget, okay? So this is like 2 over 40. So I have 2 over 40 plus 1 over 40 equals 3 over 40. And I'm still not done. This again, people stop here and say, I got it, done. No, you're not done. You're not done because that's 1 over the equivalent resistance. So 1 over R equivalent is 3 over 40. So R equivalent is equal to 4 over 30 ohms. Okay. Now let me point out something really, really useful here. Your answer for the resistance should be less than either a resistor. So here I have a 20 and a 40. 40 divided by 3 is less than 20. Okay, because 40 divided by 2 is 20. So that's a good thing to check. It should be lower than either one. There, did it. Okay, let's do a more fun problem. Okay, and you can put these in your calculator. That's fine. You can say 1 divided by 20 decimal, 1 divided by 40 decimal. Add them together. Then you got to take 1 over that. Okay, to get the answer. I see this mistake all the time. So just be careful. I don't want you to make that mistake. I made that mistake when I was a student. Okay, one more. And we could do these all day, right? We're not going to. I left off the values here. So here it's hard, right? Because you're like, oh, I have 4 resistors, so which formula do I use? Well, you don't. Because you have to say, is this in series or parallel? Is this in series or parallel with that? Well, if it's in series, it has the same current going through it. So this has a current going through it, then some goes through here. So no. If it's in parallel, they have the same voltage. They don't have the same voltage either. They're not in series or parallel. So I can't add these two. Same thing with here. I can't add those two. These two are in series. So you have to like find 2 that are in series or in parallel and reduce those to 1 resistor. So here, this is a 150 and a 100 in series. So I can find the equivalent resistance right here. And that would just be 150 plus 100. So I'm just going to write this as 1 resistor of 250. Okay. So I didn't show the math because it was pretty easy. Now I have 3 resistors. Here, this is indeed in parallel with that one because they have the same voltage across them. So I can say 1 over R equivalent equals 1 over 250 plus 1 over 100. And I didn't pick good numbers because I'm a dummy. Okay. So let's do this the decimal way because I think that'll be fun, right? I was going to use my calculator, but it's on my phone. Let's see, let me pull out a calculator. I think I have a calculator in here. Yeah, I'm going to use a computer. I'm still here. I didn't plan ahead, can you tell? Okay, let's see. Okay, so R1 is 250. R2 is 100. So I'm going to say 1 divided by R1 plus 1 divided by R2. No, I did that wrong. I need another parenthesis. Okay, 71, that's good. Check this on yourself. 71 ohms, which is lower than 100, so it has to be. Now, and here's the problem, okay? I see this all the time. People try to put this in their calculator at one fell swoop. If you don't know what you're doing, you're going to make a mistake, so just be super careful with that. I would say 1 divided by 250, write that down. 1 divided by 100, write that down, okay? I guess I should do that. Let me do that real quick. Okay. One divided by 250. I knew that. Okay, I don't know why I wrote that out. Okay, so that's going to be 1 over R is 0.004, and this is plus 0.001. So it's going to be equal to 0.0. No, that's not right. I made a mistake. 0.01. That's 0.01. Yeah, so this is going to be 0.014. Now R is going to be equal to 1 over 0.014, and that's where I get that. Okay, good. So now I have this. I'll just erase it because I have a board. I can do that. Now I have this, and I got rid of those parallel resistors, and I have this, 71 ohm. Now that becomes just one resistor. I can add those together. I get 171 ohms. Boom, done. Okay, that was longer than I wanted to. Oh well.